My name is Molly, and today I'm going to be giving a talk called How to Trick SQL into Doing All the Work for You. So before we get started, just a little bit about my background. Right now I'm a senior software engineer at Kairos. We're located in Boston, and we're doing a lot of cool stuff in the healthcare space. We're trying to solve what we call the patient access paradox. And what that means is that there's a mismatch between patient demand and provider supply. So we deal with a lot of patient and provider data. So today we're going to go over a problem we are having with one of these sets of data. We're going to go, what is the problem, go through the current process or the process before we fixed it, our solution, and then go through any takeaways. So what are we talking about? What was the issue? So we signed a customer, and we needed to implement one of our products for them. They had many millions of patient records, and we needed to import those into our database. So this was the first time that we had ever needed to import such a large set of data at once. And in fact, it is twice the amount of data that we currently host in our system for patient records. So we had a lot to consider. Could we handle this much data, and how would it affect our downstream systems? But today we're going to talk about how we optimize the data load process. So we're talking about patient data, but it's not super exciting. So let's pretend we're actually going to import SpongeBob characters today. Make it a little bit more fun. So here is an example of what the data might look like. And this is what we call a Json lines file. If you're not familiar with it, all it is a text file where it has one record of JSON per line. So you can see the first line, we have SpongeBob, second line, Patrick, third line, Squidward, and so on. So how would we typically ingest it? Well, we'll keep the data file on S3. And if you're not familiar with S3, it's just a cloud storage system. And we would then invoke a script that would post each record one by one to our Flask API. Then that API would interact with our Postgres database and insert each record one by one. We estimated that this would take about 48 hours for this size of data. Why is this so slow? 1 million records is a lot, but it's not that many. Our issues were that we were doing a network request for each and every patient. And then when we do make that request to our API is going to open a transaction with our database. It's going to insert that record, and then it's going to commit it. So that's a lot of steps for just one of the millions of records. So processing one by one is really slow in this case. So if it's the one by one processing that's our bottleneck here, can we do any bulk processing? Well, so we have a Postgres database. And if we look at the Postgres docs, they actually have a command for exactly this. Bulk copy is optimized for bulk loads of data. It's optimized over the insert statement, which we were using previously. So how does copy work? Well, it takes data from a file, and that file needs to be formatted to exactly match the structure of the table. So if we go back to our SpongeBob example, we were keeping track of the first name, the last name, and the type. So for SpongeBob, it was first name SpongeBob, last name SquarePants, type sponge. We would need to import that data with a file that looks something like this. So this is just a CSV, or an example of a CSV. So every line has a comma-separated list of the character. So SpongeBob, comma, SquarePants, comma, sponge. One string per line. OK. So what are our requirements? Let's assume we're going to use copy from here out. So we know we need to import data from a file, and that file must be a CSV that matches the format of the Postgres table. Are there any issues with this for our use case? Well, we don't actually have the file. We're going to invoke this command from our API server. But remember, our file is on S3. So that's our first issue. Our second issue is the file's JSON lines. It's not in a CSV format, and it's definitely not in the format that matches the table. So let's dive into our first problem. So our data right now is on S3, and we need to use it from our Flask API server. Well, Why not just download it? That seems simple enough. We should be able to download a file. So we could, but that's going to cause some issues downstream. We want to be able to keep our API servers lightweight. These are just simply taking requests and feeding them on to our Postgres database. And these files are really large. So we don't want to have to upsize our servers and make them even bigger for just a temporary file. So what if we streamed the data? What does that mean? So there are many ways that you can get data out of S3. And one of those is you can use an authenticated URL and Python requests. So you can just do a GET request and use the stream equals true option. And this is from the Python request library. That'll return you a generator. If you're not familiar with what a generator is it's a function that acts as an iterable. So you can either iterate over a generator in a for loop, or you can access each element one by calling next on the generator. The important piece of information here is that by using the streaming option, we're not actually downloading the file. We're keeping an open connection from our Flask server to S3, and we can get each piece of data one by calling next. So here, if we print s3 data.next, it's going to print our first line, our first JSON line, the SpongeBob character. Great. Let's go back to our requirements. Well, requirement number 1 says we need to import data from a file. That's not a file. That's a generator. So let's go back to copy. When we're invoking our copy command from our Python app, we're going to use CyclePG. CyclePG is just a library that you can use to interface with Postgres. So CyclePG has a copy from command. This just invokes the Postgres copy command. You can see it takes a file as a parameter. If we look a little deeper, the file parameter is actually taking a file-like object. And that object needs read and readline methods. So what does that mean? What's a file-like object? Well, a file-like object is a file-oriented API. Okay? So this means that it needs to have read and maybe a write function. It should behave just like a file would. And more importantly, this may give you access to a real on-disk file, but not necessarily. It can give you access to another type of storage. So we have a generator. Can we make our generator look like a file and behave like a file? Let's compare the two. So if you want to get a piece of data out of a generator, you call the next function. For a file, you call the readline function that reads one line out of your file. Those seem pretty similar. And then when a generator reaches the end, it raises a stop iteration exception. A file, on the other hand, returns an empty string. So let's see if we can disguise our generator to look like a file. We'll create a class, and we'll call that class file-like for now. We need to initialize our class with our generator. So here, self.data is going to be that generator pulling data from S3. We know we need a readline function, and a readline function reads a single line from a file. So similarly to a generator, why don't we just get the next element from that generator? Great. We also know that generators end with a stop iteration exception, but files end with an empty string. So let's catch the exception and instead return an empty string. Awesome. According to our copy command, it also needs a read function. Technically, read behaves differently than readline. It takes a size param and reads up to that size. But with a little testing, we discovered it works fine to just call readline here, at least for this use case. So let's go back to our generator. We have our generator of S3 data, and we can call next on it. But let's pass it to our file-like object. Now, we can print the next line of that file-like object, and this time, it's printing the same thing. The key here is we're calling readline. We're not calling next. And readline is the function that our copy command requires. Awesome. So back to the requirements. We need to import data from, this time, a file. And we got that. We can read from it. Our second requirement is that we need the file to be a CSV, and it needs to match the tables format. So let's go into that a little bit. Remember, this is what our data looks like. We need to convert one line of JSON into one line of a CSV. And how do you do that in Python? Well, Python has a handy package called Csv Writer. Csv Writer will ensure that your data is properly formatted and escaped to be written to a CSV file. It doesn't take JSON, it takes a list. So in this case, we want to pass the list of SpongeBob, SquarePants, and Sponge, and then it'll write to our file, write to a file, SpongeBob, SquarePants, Sponge, as a string. You might think at this point, why aren't we just using string formatting? This is a really easy string to format. Well, remember, CSV Writer can also escape things for you. So if we look at Gary, Gary has a space in his last name, the snail. Our CSV Writer will escape that space for you. Okay, so it seems like we should use a CSV Writer here. But there are a couple important distinctions. So a CSV Writer also takes a file-like object. But typically, when you're using a CSV Writer, you're writing one large document. Remember, we want to call this in our readline function. We don't want to write an entire document. So we want to be able to put data into the writer and then pull it right back out. Well, that sounds a little bit like a queue, right? A first in, first out queue. So why don't we make another file-like object? We'll call it file queue. When we write to it, you're just putting data into the queue. And when you read from it, you're just getting that same data right back out. So what's this data transformation process look like from start to end? Well, we have our JSON. Then we need to convert that to a list somehow. Then we're going to write that list to our file queue by using CSV Writer. And then we can read that right back off of our file queue, and we'll get our CSV line. So let's add it to our class. We know we have, so this is our class from earlier, and it's returning us lines of JSON, but we want to return lines of CSV. So let's initialize it with a file queue, the thing we just made before, which makes our queue look like a file, and our writer. We'll pass our file queue to our writer, so the writer can write to the queue. Let's forget about read for a minute, since it's just doing the same thing as read line. We'll move this down, and we'll access our data this time. So now data equals our CSV line, or our JSON line. So first we need to convert the data into a list if we want to pass it to our CSV Writer. Let's pretend that we have this prep for CSV function that does this for us. And so now data for CSV should just be a list where the first element is SpongeBob, the second one is SquarePants, the third is Sponge. Then we'll write a row using our writer, and remember that's writing to our queue. Okay, so now we have one element in our queue. Well, we can just pop that right back off of the queue and read it, and then we'll return it. So this time, this is the exact same code as before when we were reading a line from our file-like object, but now it prints a CSV. Awesome. So back to our requirements. We can check this off. Now the file is formatted as a CSV, and it matches the format of the table. So we're finally ready to execute our copy statement. We've set up all the pipes. We're reading from something that looks like a file. So let's see if copy will understand it. So we need to pass the table names. Let's say we're importing the SpongeBob characters and the columns to the function. Then we'll invoke the function, or invoke the command, pass it our file-like data, the table name, the columns, and we'll make sure it knows that the separator is a comma. So this works. Good job. Okay. But wait. Wasn't this whole talk about tricking SQL into doing all of the work for you? Did we do any SQL here? No. We did one SQL command. But remember, we created a file-like object. We're not reading from that object at all. It's actually the copy command that's reading it for us. So we tricked SQL into doing this formatting as it's reading the file. So that's pretty cool. All we did was set up the pipes to stream something from S3 through Flask and into Postgres without doing any reading or processing ourselves. We just set up the commands for it to pull. So what does this look like now? What's the new flow? Remember, as we were doing it one by one, it was really, really slow. It was going to take us 48 hours. So now our data still lives on S3, and we still need to invoke a script. But this time, we're hitting a new endpoint. And this endpoint takes a file param. That file should point to our raw data on S3, our JSON lines file. And then our Flask server will send a request to Postgres, and Postgres will read the file. And as it's read, it's formatted into the format it needs. So the whole point was to make this faster, right? Were we faster? Well, it was going to take 2 days originally. Now it takes about 20 minutes. Awesome. So just a quick takeaway. Objects might not always be what they seem. We took a generator and a file, and a queue, and made them look and behave like files. And so in terms of the CSV Writer and in terms of the copy command, they believe they were files. And so this is commonly referred to as duck typing. And something that's duck typed passes the duck test. Or in other words, if it walks like a duck and it quacks like a duck, then it must be a duck. Or in our terms, if it reads like a file and it writes like a file, then it must be a file. Thanks, you guys. That's the end of my talk. If this is interesting at all, come find me after. Reminder, I work for Kairos and we're hiring, so come find me outside. Thanks.